Hello guys. So yesterday we had already solved this problem count sub-islands, but I felt that there are some modifications, some more efficient ways to solve this problem. Hence a new video. I hope you don't mind and you would enjoy this. So in this video, what I'm going to say that let me just start with a brief explanation of the problem. So the problem is that we are given two grids, grid 1 and grid 2. We have given two grids, grid 1 and grid 2. So grid 1 contains 0 and 1 and grid 2 contains also, it's also a binary matrix. So it also contains 0 and 1. And we need to count the sub-islands. So the problem name itself is count sub-islands. So whenever you hear count islands and all these things, then immediately DFS should come to your mind. Okay. Count islands, sub islands, whatever is this, DFS should come to your mind. DFS should flash. Okay. If you are asked to find the, minimum path, maximum path, all those things, then DFS with backtracking also will come. Okay. So in this case, definitely we are going to use DFS because we are having this count sub island. So we have to find the count of the islands. Now let's go ahead and proceed further into the details of this problem. An island is a group of ones. An island is a group of ones, okay, connected four diagonally. Four diagonally is horizontally or vertically, okay, horizontally or vertically, okay. Any cells outside of the grid are considered water cells. Any cells outside of the grid, any cells outside of the grid are considered water cells. So these are, one cells and these are water cells. Okay, these are one cells and these are water cells. Okay, now an island is considered sub-island. So see, we're not just allowed to count the islands, we are asked to count the sub-islands. So what are sub-islands? An island in grid 2. An island in grid 2. This is the grid 2. Okay, this is the grid 1 and this is the grid 2. So this thing is the grid 2. This thing is the grid 2. Okay, and this is the grid 1. This is the grid 2 and this is the grid 1. This is the grid 2 and this is the grid 1. So sub-island will be occurring in the grid 2, not in the grid 1. Okay, so an island in grid 2 is considered sub-island if there is an island in grid 1. So if this is an island in grid 1 that contains all the cells that make up this island in grid 2. So see this island is contained in this island in grid 1 because all the cells here are there in this island. See this island is contained here in this cell. This island is contained here in this cell. See, this cell is not, counted. Only these two things are counted with this. So this cell is not counted. And you see, this is there, this is also there. But since this is connected with this bottom cell, this bottom one is here as well. But this is connected with this. And since this is part of this island, so this is not totally connected with, within this, this island system is not within this, sub-island system. So this one is not counted. I mean to say that for this to be counted, it's all adjacent islands ground cells should also be part of the, in the grid 1 also. But see, these cells are not there, in the grid 1. These cells are water cells. The corresponding cells in the grid 1 are water cells. So they are not considered. So with this thing, we'll go ahead and now we will try to solve this problem. Fine. So now we'll start. So we'll take grid 2. Grid 1, grid 2 doesn't matter. Both have the same, dimensions, m cross n. So it doesn't matter. But since we are going to operate on the grid 2, so we have, it's better, it makes sense. better sense says that we should be, dealing with grid 2. We should be iterating over the grid 2. Now, the thing is, if grid 1 of I, j is 0 and grid 2 of I, j is equal to 1. If this is 0 and this is 1, okay, then what we are going to do? So suppose this cell is 1, but this cell is corresponding cell over there in grid 1 is 0. These cells are 1, but the corresponding cells over there in the grid 1 are 0. So in these scenarios, what we are going to do, we will start one DFS. So suppose the DFS starts at this cell. When the DFS starts at this cell, it will traverse all these 3 cells. Okay. And what we are going to do in the DFS, we are going to start the DFS in the horizontal and the vertical directions, and will mark all the cells as water cells. Water cells will be meaning that these cells have been visited. So once they are visited, we should not be, these cells will not be counted in the other cells. Okay. So, and one more thing, this cell also will be, considered as water cell. I mean to say in this scenario, because in grid 1, grid ij, it is 0. Okay, yeah. So this important distinction in grid 2 ij, this is 0 and this is 1. So we need not be bothered about this, because we are going to traverse only on grid 2. And once we are marking all these, cells which are not there, which are not land cells in the grid 1 as water cells, then, you know, then what happens that, the number of sub-islands only remain those islands which are actually there, which are sub-islands of the, grid 1. So hope this is clear. If there is any doubt, please let me know. So I'll just write visit grid 2 DFS, okay, and then grid I, j, like this. And then at the end of this, we'll start this count variable. And since we are going to traverse the, graph, I'm going to say the matrix again, so it makes sense that we do the things like here. So now in this case, what we'll do that, this is also 1 and this is also 1. And then we'll do, plus count before starting any, any grid traversal. And then afterwards, we will be returning this. Okay, and then private void grid, oh, I meant to say visit grid to DFS okay, if rho is less than 0 or rho is greater than equal to grid dot length, because rho is, it should be within 0 and the number of sub-arrays is returned by grid dot length. So rho should be 0 and grid dot length minus 1. It should not be more than these values. So all these less than 0 and greater than equal to grid dot length are outside the boundary of the grid. Call is less than 0 or call is greater than equal to grid of rho dot length or grid of rho call is equal to 0, then return, okay, grid rho call is equal to 0, and then we will take this visit grid row plus 1 call. So we'll copy this row minus 1 now is the term of a call plus 1 call minus 1. So that's it. Like this will do. So basically what we have done that, this is the pre-processing that we are handling. And in the pre-processing, what we are doing that beforehand, we are marking those cells which are not there in grid 1. We are marking those land cells in grid 2 which are not there in grid 1, because in the final countdown we are not concerned with those cells. We are only concerned with those cells, those land cells which are also land cell in the grid 1. Okay, so see, when you are doing DFS, when you are coming for doing DFS over here, since this is also there in the grid 1, so we'll traverse this whole island, because this whole island is there in grid 1. So we'll traverse this. This is the one island. Now, once we reach here, so because this part is the, once we reach here, then because this part is not there in, this is a water cell, so we are not going to bothered about that in grid 2. So we'll be only concentrating on this. This is there in this, so we'll counting this. And since it is not horizontally and vertically or horizontally connected with any other cell, see, this is diagonally connected. This is not horizontally or vertically connected. So that's why this is separate island. This one, this particular island where my mouse is hovering, this one is a separate island, and this one is also a separate island. So these two are separate islands. Okay. So these two are separate islands, and this is once we reach over here, then we are starting our, because this cell is there in grid 2, but this cell is 0 in grid 1. Grid 1 ij is equal to 0, but grid 2 ij is equal to 1. So this is 1 and this is 0. So that's why we are doing one DFS traversal, and we are marking them as visited. Once you are marking them as visited, so these are all water cells. So in the final countdown, this will be counted, this will be counted, this will be counted, and these whole land cells will not be counted. And that's what the answer we want. So hope this is the explanation that you wanted, and now things are clear to you. So let me know. And the final DFS thing, if you see all my island problems list, this is the same same procedure that I have used, and I thank Tausif Liaquat for teaching me this method of grid traversal. Whatever I know it is because of Algo Labs and Tausif. So thanks a lot to them. Thanks a lot, and hope this explanation is clear to everyone. With this, I would like to say thanks. If you have any other doubts, please post it in the comments. Thanks a lot.